So today we have Tomm Stubbs from Chronomics. Thank you so much for being here. Would you be able to give us an overarching view of what Chronomics do?
Sure. So at Chronomics, we are creating objective measures of health to deliver a future of prevention. So whereas today, most people are focused on building biomarkers of disease to measure ill health, we're focused on building biomarkers of health so people can avoid disease.
Interesting. I mean, would you be able to tell us a little bit more about your background and then kind of how you arrived here? Would that be okay?
Yeah, sure. So my background, I did my undergrad at Oxford University in molecular and cellular biochemistry, left there and went to Cambridge to do a master's in semiconductor physics applications of biology, and then a PhD and short postdoc at the Baber Institute, where I was supervised by one of the founders in the field of epigenetics, Professor Wolf Reich, and the technical co-founder of Selexa that then became Illumina, Professor Shankar Balasubramanian. And I was building epigenetic predictors of aging and developing different tools for the study of epigenetics.
That's incredible. I mean, could you tell us about like the genetic sequencing technology so far and kind of how far it's come, and you know what's the state of it, and then also from a cost perspective, because from my understanding, it's dropped drastically.
Yeah, sure, happy to. So I think there's an important distinction as well to just get out kind of in the is that so as a company we're primarily focused on delivering epigenetic biomarkers, which are distinct from genetics. So your genetics is what you get from your mum and dad and is fixed from birth, so it doesn't change, and it's, you know, determines what colored eyes you're going to have, whether you're going to have curly hair or not, or whether you're going to be at risk for certain inherited genetic diseases. Epigenetics, on the other hand, is the science of how your DNA is controlled, and it's affected by environment and lifestyle. So the DNA in your cells is not naked. It's constantly wrapped up in clothes that we as scientists call epigenetics.
Would you be able to kind of give us an oversight of what the epigenome is and like a tangible example of maybe how it may differ between, say, twins?
Yeah, sure, happy to. So yeah, twins is a great example. So there are people that share the exact same genetic material, so identical twins, and yet they can have very different health outcomes. And so the reason for that is that they have different environment and lifestyles. And measuring epigenetics, so defining objective health measures using epigenetics, you can pick up these differences. So essentially you can provide people with information about their health state today so that they can avoid ill health in the future. So to give a specific example, kind of distinction between genetics and epigenetics, genetics could tell you how likely a newborn baby is to become obese as a kind of predisposition, if you like. Epigenetics can give you information about somebody's metabolic risk today at an up-to-date level.
That's really interesting. So do you think like lifestyle can actually change the odds of somebody getting like an age-related disease then, more than their genetics? Or is that relative?
Yeah, absolutely. So I think one thing that's like super important and why we're really passionate about epigenetics as a space is that the majority of age-related and chronic conditions that affect people today are largely due to environment and lifestyle, not due to the underlying genetic predispositions in the majority of cases. So you can have things like type 2 diabetes, heart disease, certain types of cancer, etc., that are largely due to environment and lifestyle. So an example that we often give is if you look at heart disease, the genetic risk difference between somebody at low risk and high risk can be between 4 and 5-fold. So somebody can be 5 times more likely to develop heart disease than somebody else, which sounds pretty big until you put it into the context of somebody's overall kind of environment, lifestyle, and age-related risk, where the risk profile is then 5,000-fold. And so that environment and lifestyle component is so much more important than that genetic component for many age-related and chronic conditions. But if we take aging, for instance, so you know, people, you've probably experienced this as well, like people that you know who have, or maybe your parents as well, people that live long tend to have children that also live long, etc. So so there's a genetic component to the aging process. But that genetic component of age is estimated to be between 10 and 15% of somebody's overall lifespan or longevity-related health component, with the 85% or 90% being down to environment and lifestyle, so epigenetic things that can be measured.
Yeah. I mean, in your opinion, do you think we're going from like personalized data from various devices? I mean, there's the Aura ring, there's patches you stick on your arm to track your sugar and your insulin levels. I mean, do you think we're kind of moving to a point where we're capturing really good, nuanced, personalized data to actually get actionable insights? Like, where are we on that scale right now, in your opinion?
Yeah, so there's definitely within healthcare, there's a shift towards prevention. And in order to enable that shift, we need objective measures that capture health. So for over 70 years now, the World Health Organization has defined health not just as the absence of disease, but the complete physical, mental, and social well-being of the person. And up until recently, we haven't really had any objective measures that we can use to capture that broader definition of health. And as you mentioned, there's now digital tools that people are using to try and measure components of health. So you mentioned the Oura Ring for sleep. And from our side, we're now creating objective measures of health using molecular data, so data at the level of your DNA. And this is definitely an emerging area, and it's only gonna grow.
I mean, so in terms of like, at the beginning of the interview, you made a distinction between genomics and then epigenetics. Now, I mean, there are other test kits out there, 23andMe, I think there's Viome, and there's loads of different things out there that test your genetic predisposition to certain diseases or gives you a generic overview. But from my understanding, your technology and your package kind of encourages you to track it quite often, right? I mean, how often would you kind of encourage people to use your kit, your Chronomics kit?
Yeah, sure. So for a number of years now, there have been providers in the direct-to-consumer genetic space. So you mentioned 23andMe, Ancestry is obviously another one. Then there's also been microbiome companies, so looking at your gut bacteria. So you mentioned Viome, Ubiome until recently was also another company. And what we're doing now is bringing epigenetics to the table. So taking that genetic predisposition layer that for the vast majority of chronic conditions is not super informative or not as useful as that epigenetic layer that people can actually action and change. In terms of how frequently do people take our product, so typically it's on a 6-monthly or yearly basis. We have some partners that we work with where they're doing tests more frequently than that, so on a quarterly basis as well.
Yeah, and have you seen the epigenome of somebody kind of shift on a quarterly basis, and like to what extent?
Yeah, absolutely. So we look at a range of health biomarkers from looking at biological age, where epigenetics is the gold standard of understanding not how old you are, but how healthy you are on the inside.
Okay.
Through to metabolic related things, so things related to diet and exercise, such as our measure of metabolic state. Through to also now mental health related indicators, which is super interesting.
Yeah.
And depending on the different biomarker, they have different amounts of actionability. So if we take, for instance, a good example being smoke exposure. So using epigenetics, we now have the first measure of long-term risk from something like smoke exposure. And we have people taking this on a quarterly basis through smoke cessation programs, for instance, and seeing the improvements to their health over that period of time.
That's incredible. In terms of predictors of aging, I mean, what markers does your technology kind of highlight? If you can go through it, and kind of what insights do they give us about the aging process?
Yeah, sure. So epigenetics is a really broad field of science. So you have proteins that your DNA is wrapped around called histones that have tails, so little bits sticking out that have chemical tags on them. The DNA itself has chemical tags on it, and then you also have modifications to RNA, which is another form of nucleic acid. At Chronomics, we specifically are looking at DNA methylation.
Okay.
So this is chemical tags on your DNA. And DNA methylation is the archetypal epigenetic modification. It's found in all mammals, and we need it to develop. So if DNA methylation can't be placed, in our cells, then we can't go from a single-celled embryo into the complex humans that we are today. So we need it for cells to differentiate and for our bodies to develop. And so we're looking, using our science, we're looking at over 20 million epigenetic marks, so almost the whole genome's worth of epigenetic chemical tags.
Okay.
And from this, we're deriving specific signatures for specific components of health or biomarkers. So one of them being, as you mentioned, biological age, where epigenetics is the gold standard at measuring that.
Yeah. Yeah.
And all, sorry, no.
Carry
And
on.
all from saliva,
Yeah.
I think is important to say. So
All from saliva?
yeah, so we've built all of these biomarkers from a saliva-based test. So it's non-invasive, easy to use, something people can do in the comfort of their own homes or also in clinics as well.
That's really interesting. Like you're actually able to capture all of that data from a saliva. I mean, were you skeptical at first? Because I mean, there are so many like different diagnostics companies that take blood. I mean, obviously you've got the Theranos thing where you take the prick of blood, and a lot was said about you can't capture the right amount of biomarkers from that prick of blood. Were you skeptical at the fact that you capture all of this data just from your saliva? What was the discovery process with that?
Yeah, sure. So in your saliva, you actually have quite a lot of the cells in your saliva, or DNA coming from your saliva, is from blood cells.
Wow.
And DNA is in all of your cells, pretty much all your cells, obviously your red blood cells and some others. And this DNA in all of your cells has these chemical marks on. And so we weren't skeptical about being able to use saliva. Saliva had been shown in numerous publications before. And actually, saliva has the added benefit that when it comes to, for instance, mental health related stuff, it's much more correlated to the brain methylome.
Wow.
And so you have increased likelihood of picking up stuff in that realm as well.
That's incredible. I remember listening to one of your speeches. It was about a year ago in Spain, actually.
Okay.
And you said that sites that gain methylation are enriched in the development process, and then you also mentioned sites that lose methylation are enriched in metabolism process, or
Metabolic related.
Yeah, metabolic. How does that relate to humans? And would you be able to kind of give us an easy to understand example of that?
Yeah, sure. So this was specifically relating to aging.
Yeah.
So for instance, our biological age model or biomarker. So as we age, certain bits of our DNA gain more of this epigenetic mark, more of this chemical tag, and certain bits lose this chemical tag.
Yeah.
And what we see is that, as you say, positions that gain this chemical tag or methylation are associated with developmentally regulated processes, and positions that lose tend to be associated with more metabolic related processes. And this is super interesting because people have lots of different theories as to why we age. One of which is that it's our developmental program going awry. And so being able to actually look at an epigenetic level and see what are the genes that are being altered or affected from a methylation perspective can get us closer to understanding the true aging mechanism. And so that's a lot of, back in my past life in academia, at the lab of Wolf Reich, that's a lot of the stuff that we were working on as well, was trying to understand aging at a fundamental mechanistic level.
Yeah, that's really interesting. And apologies for my lack of knowledge, but in terms of methylation, how does that kind of apply to the telomere length? Because I've watched a lot of podcasts with Dr. Rhonda Patrick on the Joe Rogan podcast, and she talked a lot about the telomere length and how that kind of shortens as you age. Does epigenetics really play a part in the telomere length, or?
So I think this is an interesting point to bring up. So telomere length telomeres are the ends of your DNA.
Yeah.
So human DNA is broken down into chromosomes or chunks of DNA, and on the ends you have telomeres. And in leukocytes, so in our blood cells, as we age, our telomeres get shorter, and they're also impacted by stress. In an epigenetic context, this biological aging process or measure happens in all cell types in your body.
Oh, really?
So it's not just linked to your blood cells, like in the telomere example. If you take somebody's skin, or you take some liver cells, or you take somebody's saliva or blood or urine, you can predict biological age using epigenetics, and you can't using telomeres. And also the accuracy of the prediction of age from epigenetics is far greater than with telomere length.
Again, going back to that talk, you talked about the acceleration of the epigenetic age can really have a massive influence on whether somebody accumulates an age-related disease. Would you be able to kind of go through that?
Yeah, sure. So biological age, as we mentioned, isn't just your chronological age. It's not measuring how old you are. It's measuring how healthy you are, or how well your body is aging. And so say you're 25 and you have a biological age of 30, we would say that epigenetically your age is accelerated. And this acceleration is associated with an increased risk of age-related diseases and all-cause mortality. And there's a number of different things that can accentuate that age acceleration. And conversely, on the flip side, if you look younger, so say you're 60 and you look 50, that epigenetic age deceleration is associated with decelerated aging processes. And actually what you see is that supercentenarians, so people that live to 110 plus, tend to have decelerated epigenetic ages.
Wow, that's incredible. And in terms of, would you be able to explain it to like somebody with an average IQ like myself? I mean, how you study DNA methylation? I mean, obviously.
How do you look at it?
Yeah, how you look at it, yeah.
Yeah, sure. So the process is not crazily dissimilar to looking at DNA.
Yeah.
So if we think about DNA using next generation sequencing or something like that, you're essentially reading off the different letters in your DNA.
Yeah.
So in your DNA, you've got 3 billion letters, two copies of 3 billion letters, roughly. And in your DNA, you've got 4 different types of letter. You've got an A, a C, a G, and a T. And when you're sequencing somebody's DNA, you're just reading out, is there an A, is there a C, is there a G, is there a T, is it a G, is it a T, etc. With epigenetics, it's not too dissimilar. So you would take from somebody's saliva sample, for instance, like we do, you would extract DNA, and then, and this is the step that's different, you treat that DNA so that you can tell the difference between when a chemical tag is present and when it's not. And so the important thing here is this DNA methylation, or this chemical tag, only ever gets put on a C letter in your DNA, and only when it's followed by a G.
Wow.
So it's a C followed by a G is where methylation, or the chemical tag, then gets put on the C. And if the chemical tag's there when you treat it, then that C stays looking like a C. And if the chemical tag isn't there, then that C looks like a T. So when you read out the DNA at the end with the sequencer, you can tell the difference between a C that had that chemical tag and one that didn't. And then you process that through algorithms to look at methylation levels.
That's incredible. In terms of you actually figuring out all of this stuff during your PhD, I mean, would you be able to kind of, again, going back to that talk, I mean, you talked about how you define a tractable model for epigenetic testing. Would you be able to give us an overarching view of that?
Yeah, sure. So one of the things that's super interesting about epigenetics and the derivation of epigenetic biomarkers is that they can be used as surrogate endpoints. So surrogate endpoints essentially means that, let's say you wanted to make a drug for to help people live longer, or an anti-aging therapy. If you didn't have a surrogate endpoint, you'd have to use the natural endpoint, which would be seeing in 50, 60 years, do people die sooner or later with or without the drug? That's obviously an incredibly lengthy process if you were going to do that, and it would be incredibly expensive. And what you can do with epigenetics is you can start to define surrogate endpoints. So you can say after a year or two, okay, this person's biological age is accelerated, therefore they're at increased risk of having kind of a shorter lifespan than somebody without the drug. Okay, let's stop that. Or conversely, you can see which drugs are looking pretty good, and then you can start to do longer trials with more certainty around them. And so what we did during my PhD was to take that a step further and say, okay, you can build epigenetic predictors of age in humans. Can you build it in a model system that isn't human? So we built the first non-human predictor of age, biological age, using epigenetics in the mouse system. And what we saw is that similarly to the human, that measure of biological age using epigenetics is affected by different interventions. So be they hormonal interventions, reprogramming related interventions, etc. And so within a couple of weeks of a mouse's life on a treatment, you knew which mice were going to live longer or shorter. And even in the world of mice, where they only live 3-4 years as opposed to humans living 80 plus, that's still a long time to wait if you're wanting to study things in a shorter period of time so that you can iterate and improve the science faster. And so having these biomarkers, these surrogate endpoints, really enables research to proceed at a much faster cadence than it could otherwise.
Yeah, and kind of going on to the second point, I mean, how did you guys develop you might have gone through this, so let me know. I mean, how did you guys develop a methylation tool for for enrichment approaches?
Yeah, sure. So so part of the work we did during research and now also in the company has been around method development. And so we've developed a method where we can enrich for positions epigenetic marks that are really interesting within the genome for variation and regions that are affected or known to be affected by environment and lifestyle or known to be important for gene regulation. So for instance, promoters and enhancers. And we can enrich for those so that we're not sequencing the whole genome, which is important from providing this service to people so that everyone can get access to it.
That's incredible. And then throughout the talk, you then went into how you defined a model for epigenetic aging at a single cell. That was really fascinating because it really delved into your research and then how meticulous you were about kind of defining it in a specific cell. Was it done with the mice, right?
So this was again using mouse models, and the reason it was done in mice is because in mice you can have mice that have the exact same genetic background. So it's much easier to, if you like, have lots of identical twins than it is in a human setting, because you can have not just pairs, you can have tens of twins, if you like, identical twins.
Can you genetically program mice to have the same epigenetics and genetics?
No, so similarly to how you can have identical twins in humans, roughly similarly you can have genetically identical mice in a mouse system. And what that means is that, that whole kind of what percentage of it is due to genetics versus epigenetics, if they're all identical, then that genetic component is out of the way and you can focus on the epigenetic component. And so what we did was to take single cells from stem cells in those mice, so cells that rarely divide, to try and start to tease apart, okay, what is the aging process? Is it due to cell replication? Is it due to stem cell exhaustion? Is it a cell intrinsic thing, like every cell has a ticking clock? Or is it something that's happening systemically? And that was what that work was set out to do.
That's incredible. In terms of your product, I'm sure we'll probably go through it in the future with an actual product demo.
Happy to.
I mean, would you be able to kind of talk about the kit, what it includes, and like what the end consumer can actually glean from it?
Yeah, sure. So the kit is a saliva-based test. So currently we sell the product predominantly through partners and channel distributors. So depending on the partner or channel distributor that a user would come through, that kit will either be sent by us directly to them, and they can provide their saliva sample in the comfort of their own home and then send it back to us in a prepaid envelope, or they come into the partner for a consultation, provide their sample in the clinic or during that consultation, and then the partner will send it back on their behalf to us. Once we get that sample, we then process it through the wet lab to assess these millions of epigenetic marks that we talked about, that enables us to then, with machine learning, derive these specific signatures for these different health measures that we give back to people so that they can stay healthy for longer. And we give them back to people through a digital product, so people can access them anywhere through an app.
Yeah. That's incredible. And so the journey for a consumer is to obviously take it from the healthcare provider, because I believe you mentioned before the interview it's a B2B to C type of model.
Yeah, so we sell through for instance, health coaches, healthcare providers, corporate wellness providers, longevity centers, addiction centers, so lots of different types of partner. Basically anyone that's engaged in supporting people with prevention and living healthier and longer lives.
Do you think you'll move to a B2C model, or is that still in place? Can people just purchase a kit online from you?
Yeah, so predominantly we sell through partners and channel distributors. We do have B2C customers. So when we started the company, we were selling direct to consumer. And what we've since found is that it's a much better route to market going through the partners and channel distributors.
Yeah. Okay. And in terms of you guys, in terms of getting here right now, I mean, it couldn't have been an easy journey for you. I mean, what advice would you give somebody that's actually trying to take their scientific research and actually commercialize it? I mean, it's a nuanced process and probably a difficult process. I mean, what are the things that you've actually learned about going through that?
Yeah, I mean, I think the first big distinction, if you're coming from a science background, is you think in terms of experiments, and you think in terms of like perfect study designs, things like that. I think the first thing you realize or you learn very quickly is that in business that doesn't really work. And you kind of have to rip up those perfect designs and start thinking how you can get what you need to achieve from a science perspective, but in a real world setting, where there isn't this perfect controlled setup that you have within an academic context.
I mean, is that something? Was that like a rude awakening for you? Did you figure that out halfway through, or did you have advisors that kind of guided you through the process?
Yeah, so we were lucky in that we had a great couple of advisors who were kind of supporting us with that. But it's something you realize very early on, basically. So within the first couple of days of founding, you're like, okay, we need to think about this from a business perspective, not from a scientist perspective or academic perspective.
How was that mentality shift for you? I mean, did you always know you wanted to kind of commercialize some of your research, or was it something that you just stumbled upon?
Absolutely not. I mean, I was very keen to go down the academic path. So say in the first instance, you could call me a reluctant entrepreneur, but knew that what we were doing in academia had incredible value to people today, and seeing the rise of direct-to-consumer genetic testing and the importance of genetics globally, and the message that consumers were getting from this is that we're predetermined, we can't do anything about our health, we're screwed basically. And the epigenetic version of that is actually, no, hang on a minute, most of the risk for most of the stuff you're going to die of, you can control. It's environmental lifestyle derived, and now you can measure at a molecular level to understand how to stay healthy.
That's incredible. And I mean, throughout this journey, I mean, you went through the Rebel Bio process. How was that, and how did you find it useful?
Yeah, so that process was fantastic, and I'd definitely recommend stuff like that if you're coming from science or from bioscience perspective into founding a company, because they support you or nurture you, if you like, as entrepreneurs through that switch, if you like, from thinking like an academic to thinking like a business person. And
was it a quick switch for you, or was it something that you kind of, because you said you were an accidental entrepreneur.
Reluctant
entrepreneur. Was that switch quite quick for you, or was it something that you kind of had to nurture yourself into? Or
I mean, it's pretty quick, I would say. Like within a week, like quick. But it's a very abrupt, different way of thinking. And it was great to have the support from the advisors in reinforcing that new way of thinking at that time.
I mean, I was really interested to know your perspective on, say, the direct-to-consumer model from a healthcare perspective. I mean, it's something that we're seeing quite often. I mean, we spoke to a company called TestGuard, and they post cards, and it's a diagnostics tool, and you get to diagnose certain sexual diseases and things like that amongst men, which is quite a taboo subject.
Yeah.
I mean, how are you finding that the space evolve now? I mean, a lot of the companies in this lab we're seeing kind of take the preventative approach to healthcare, whereas before it was the Band-Aid approach. How are you seeing this space evolve, before your very eyes? Because you're in the thick of it right now.
Yeah, absolutely. I mean, definitely there are a couple of trends happening in healthcare.
Yeah.
One is that individuals, people are taking more ownership of their health and demanding more ownership of their health. And the second is that, as you say, there's this transition from waiting until you're ill before seeking help to prevention. So there's that kind of traditional generalist and reactive healthcare through to now personalized and preventive, as you say. And there's a whole host of things coming out in this space. To me, what's super exciting from the epigenetics side is that just at a fundamental level, DNA methylation or epigenetic-based biomarkers are incredibly useful for long-term risk information. And we're really excited to be in this space, supporting people living healthier lives.
Are there any specific regulatory changes you would just love to see and would actually be really beneficial for Chronomics?
Good question. I mean, I think there's a lot of regulation that still needs to be worked out when it comes to prevention. So if you're creating biomarkers of health, is that wellness? Is it diagnostic? Where is it? There's still a lot to be worked out in this space from a regulatory perspective. And we're helping as well with a number of discussions to support that dialogue from the business side. And I think, it's incredibly important for consumers. And, we're already seeing stuff happening with data privacy legislation.
Yeah.
It's only a matter of time before things catch up from the prevention regulation perspective.
I mean, in terms of, what have you learned about building product, throughout your journey?
Yeah, I mean, this has been an incredibly interesting journey, and definitely something that's still evolving and continuing. From because for us, product as a deep biotech company that's got a user-facing product. Product means a lot of different things. Like there's that functional front end, but then there's a back end, and then there's back stuff. There's a lab, etc. So there's a whole host of different things to think about. But definitely one of the key things that we keep focusing on and will continue to focus on is the customers, the users. What does the individual want? What can we give the individual to enable them to live healthier and achieve the goals they want through the product that we're offering?
That's incredible. So obviously taking a consumer-centric approach.
Absolutely, yeah.
One thing I was really curious to know about was, is there when you're creating a deep tech company, do you have to strategically kind of innovate or kind of strategically reorganize your lab to kind of meet a certain product demand, or kind of set your lab up for continuous improvement or continuous innovation? Yeah, I mean, from the lab and also from the data side, you have to set yourself up to be able, in an automated way, to be able to handle demand. But then you also need to keep it agile and responsive enough for additions to be made and developments to be added into those pipelines, if you like. So there's a really interesting balance between, you're not just sorting out the logistics and whatever, you're actually trying to develop new and exciting science and new biological assets at the same time, and new ways of doing things. And so you just need to keep your processes agile to that. But it's definitely an important consideration for sure. Is it something that you continuously think about and continuously try to iterate? I mean, you as for us as a deep science company, you don't want to be, you don't want to be putting yourself in a position where you're unable to iterate because you're too rigid as a process. And so there's constantly thinking around, okay, how are we staying customer centric, keeping that agility in the back end. That's incredible. We're going to go to a quick fire round. Is there a book that you would gift to a fellow biotech founder?
So I'd say as biotech scientists, we probably understand what we're doing very well at a biological or science level if you've done PhDs or postdocs in the thing. And it's often quite difficult to translate that to people, to consumers. And so one book that I thought was really good for getting to understand how to deal with that is Made to Stick by Chip and Dan Heath, which is just about, again, the simplification of messages and how you get people to understand in that simple form without losing meaning what you're doing, what you're selling, what you're trying to say.
Favorite purchase or most valuable purchase under £100?
Under £100, most valuable purchase. I mean, it would probably be books. Like no book in particular, but yeah, I like reading.
Amazing. Most valuable advice you've received?
Can I give two?
Yeah.
Two most valuable pieces of advice. One, which I'm sure he'll love me saying this is the most valuable piece of advice, is that sales solve everything.
Yeah.
So it doesn't matter whatever problems you're having, whatever's going wrong, sales solve everything.
Yeah. And
just have that in your head. And the second piece of advice is essentially as founders of startups like this is never to lose sight of the fact that you are the people who understand what you're doing the most. That doesn't mean don't listen and take input from other people. It just means be aware that you are the people that understand what you're doing the most.
Is there a valuable failure that's in hindsight set you up for success or kind of moved you along the journey to where you're at right now?
Yeah, I think one thing that you actually brought up earlier a little bit was the blood versus saliva.
Yeah.
And at the start we were like, okay, blood or saliva, like what tissue should we go for? And at the time it wasn't really necessarily a failure, but we were having some challenges with getting the blood prick devices to give robust results in the hands of users and things like that. And so we're like, okay, we're going saliva then.
Damn you, Theranos.
And actually, as it turns out, saliva is a fantastic tissue for a number of reasons on the biological side, but actually also from a usability side and being able to distribute globally with reduced regulatory hurdles because it's not classed as a biological specimen. There's a whole host of benefits that have come from using saliva. But it wasn't necessarily something that when we started coming from the science perspective, we were envisioning going down. Yeah.
That's incredible. And what's your favorite restaurant, or actually we'll go for, what's your favorite junk food?
Junk food?
Yeah.
In terms of like...
Anything.
I
mean, I'd say crisp for me, but yeah.
Crisps? No. I mean, I do like a good burger.
A good burger.
Yeah.
And what gives you the most fulfillment in terms of what you're doing right
now? For me, the most fulfillment comes from seeing the science of epigenetics in the hands of people and people understanding what it means. That for me is the most powerful thing to see, is that we have, because when we founded the company, we wanted to bring epigenetics out of the lab to people so they could benefit from it with the mission of improving lives by making health actionable. And actually seeing it in the hands of people and people understanding it, engaging with it, and it improving their health has been, the thing that gets me out of bed in the morning, for sure.
That's incredible. Thank you so much for being on Tech Talk London. Really appreciate this. And we'll probably do a product demo at some time in January.
Awesome.
Thank you.
No, thanks for having me.
Let's call it a day.